So this is a picture, again, just kind of repeating what the difference in pH. I added the stuff in purple because it helps me to remember that too many acids weigh down the pH. That's the direction the pH is going to go if I have too many acids. And then the pH will go up with too many bases. So, if I add to the base of my house, it's going to get taller. And so that kind of helps me remember. And I put these on here just kind of as a visual. I'm going to walk through the one up on the left. So typically we have a balance between carbonic acid and bicarb. In the case of respiratory acidosis, we have breathing being suppressed. Now, whether it's because the rate is slow, the depth is shallow, or we have a blockage of some kind, CO2 is building up. So our ratio changes. Now we have too much carbonic acid. Because we have an acid, our pH is going to go down. But because it's CO2 or carbonic acid, our PCO2 is going to go up. In primary respiratory acidosis, nothing is going to happen to the bicarb. It hasn't kicked in yet. Okay? So initially in respiratory acidosis, for some reason I'm retaining carbon dioxide, my pH goes down, my carbon dioxide goes up, my bicarb stays the same. Once the kidneys decide, hey, I should do something about this, and kick in, they're going to start to conserve bicarb and getting rid of hydrogen. And so we have more bicarbonate to try to correct it. At this point, I'm going to start to see the bicarb elevate a little bit on my ABGs, and the pH starting to come back up, or maybe even be in normal range. I may need to do something about it, and if I do use a lactate, like lactated ringers, that helps to increase the bicarb faster. So mainly the first two slides, or first two squares, or rectangles, or whatever, is what I want you to look at. And I did one on alkalosis. So metabolic balance before, again, we have our ratio, 1 carbonic acid to 20 bicarbs. With metabolic alkalosis, automatically with alkalosis, I know that I have too much base because I have lost, either I've increased my base, the kidneys are conserving too much, or I've ingested it, or whatever. But in my ABGs, my pH is going to go up, and my bicarb is going to go up. Nothing happens with my PCO2 because the lungs haven't kicked in yet. Once my respiratory system decides to kick in, the goal is going to be to retain carbon dioxide. So that means my body is going to change my respiratory rate and depth to slow it down. The kidneys, at the same time, if they're functioning properly, will start to eliminate bicarb and conserve hydrogen. Okay? At that point, I'm going to see that my pH is coming closer to normal, my PCO2 is increasing, and my bicarb is coming down. So when I have a change in only two things, that's a primary change. So that leads me directly to determining whether it's respiratory or metabolic. So if it's a change in pH and PCO2, it's primary respiratory. If it's a change in pH and bicarb, it's a primary renal or metabolic. When that third thing starts to change, that's when I know I'm compensating. So I'm trying to do something to correct the problem. Anyway, I just thought it was a nice visual, and maybe it isn't helpful, and if it isn't, let me know. Okay? So what can cause acidosis? I've already talked a lot about respiratory acidosis, what can cause that. Anything that decreases the rate and depth of respirations is going to cause acidosis, respiratory acidosis. Now, metabolic acidosis, with metabolic, I'm not going to see a rise in my PCO2. That's not what is being affected. It's the fact that I don't have enough bicarb in relation to the number of metabolic acids that are available. So some things that can cause it would be renal failure. If my kidneys aren't working, they can't excrete the hydrogen ions. Salicylate, which is your aspirin, is an acid. The body converts it into an acid. If I take too much, then I've got too many acids in my body that can't be compensated for by the bicarb. Diabetic ketoacidosis. The blood sugar goes too high, body can't use it, it starts breaking down its own tissues. A byproduct of that breakdown is ketones. Ketones are acidotic, thus I'm going to have metabolic acidosis. And potassium levels increase in acidosis. And again, this is because one of the ways the body will attempt to compensate will be to put hydrogen inside the cells in exchange for potassium. And that's not necessarily an effective compensation, but it's what occurs, and so I have to be aware that I'm looking for that increased potassium as well. Alkalosis, again, respiratory, anything that causes rate and depth to increase. So fever, high altitudes, anxiety, those are things that make me breathe faster, make me breathe deeper, and I'm getting rid of too much CO2. So my pH is going to go up because I'm alkalotic, and my CO2 or my acid is going to go down. Metabolic acidosis is, or not acidosis, but alkalosis. I'm kind of getting tired. Metabolic alkalosis, I've got an increased pH, increased bicarb. Remember, bicarb and pH go the same direction. Excessive vomiting or excessive gastric irrigation. I'm losing those acids. Okay? So I can't utilize them the way my body might need to. They're not going to be a source of hydrogen. Potassium wasting diuretics are going to take hydrogen along with them. Overuse of antacids. I'm neutralizing those gastric secretions, and so again, I don't have those hydrogen ions available, and they're going to Therefore, my bicarb ratio is going to increase significantly. So compensation, I've alluded to a couple of different times. Compensation occurs in the opposite system of where the initial problem is occurring. So compensation is trying to help maintain the pH. So if I have a primary metabolic problem, the change is going to occur in the respiratory system. So if I have acidosis, metabolic acidosis, my pH will be low. No, that's not true. I just lied. What I might see is a low pH or a normal pH. My bicarb will be low because it always goes with the pH. But my PCO2 is going to be low. Why is my PCO2 low? Because I'm getting rid of that carbonic acid in order to reduce the number of acids in the body and bring the pH up. So alkalosis, metabolic alkalosis, again, the pH might be normal because of compensation. Bicarb is still going to be elevated because it hasn't corrected yet. And the PCO2 is going to be elevated because I'm retaining the hydrogen ions or the carbonic acid in order to stabilize the pH. Okay? So if I have a normal pH or a relatively close to normal pH, but the other two things are altered, then I have a primary problem with compensation. So with the respiratory system, changes are going to occur in the kidneys. So again, if I have respiratory acidosis, I expect my PCO2 to be elevated because I'm retaining that carbonic acid. My bicarb is going to be elevated because it's trying to neutralize those acids and maintain a balanced pH. With respiratory alkalosis, I have a low PCO2. I've blown them all off. But my pH is going to be normal because, and this arrow is wrong on the bicarb, because I should be getting rid of bicarb in order to stabilize that pH. So anyway, acid-base balance in a nutshell, it's a very difficult concept to learn, and you really want to go through it several times. There's more information there probably than you need, but you just want to understand the process. And the process is that the respiratory is CO2, the metabolic is bicarb, and it's all about maintaining the pH. And CO2 is an acid, it's going to lower your pH. Bicarb is a base, it's going to raise your pH. And what am I going to see? Why is that going to happen? Why am I going to have respiratory acidosis? Why am I going to have metabolic acidosis? And what am I going to do about it? How does the body change? And what do I need to change? Okay, so thanks for listening, and on to the next step.